This week we're focusing on domain of number and operations in base 10, which is foundational in early childhood mathematics. Understanding this area is really critical for developing the skills students will need as they move into more complex mathematical concepts. So I want to not just explore the conceptual understanding that precedes procedural fluency, but also take a look at how learning theories shape our teaching practices. In addition to this, we'll talk about how to evaluate high-quality instructional materials to ensure that they support the development of a strong foundation in mathematics. So by the end of this lecture, you are going to be able to apply and evaluate methods commonly found in high-quality instructional materials for teaching and number operations in base 10, analyze student work to identify misconceptions and develop targeted instructional plans to support learning, as well as analyze research on the importance of conceptual understanding before procedural fluency. When we emphasize conceptual understanding before procedural fluency, what we're really doing is tapping into the constructivist theory of learning that we've talked about in a couple of our meetings. So the constructivist theory was influenced heavily by Piaget, and it really suggests that students construct their understanding through hands-on experiences and reflections on those experiences. So they're basically building the scaffolding that goes into their mind as they're experiencing something. So when we look at this in terms of base 10 and number fluency, we can think about a student. So they're working on 14 plus 9. If we just teach them to memorize what 14 plus 9 is, or the steps that they would use to do it, like because it's going to be more than that, you're going to carry the digit, those types of things, when we're really just emphasizing a process, that's not really going to help them understand why they're doing it. And so as a constructivist, we step back and we say, how can we help the learner construct the knowledge and not just feed them a series of steps? Feeding them a series of steps can be good in some ways, but in others we want to get to a fluency point. So what we could do then is use base 10 blocks and let them break the numbers into tens and ones, and then they can physically show them how they need to regroup instead of just telling them. So especially for our kinesthetic learners, if we are showing versus telling, that's going to be really beneficial. This experience also builds their conceptual understanding of addition before they become fluent in performing the operation. The constructivist approach aligns really well with the belief that students must engage in concrete experiences before moving to abstract thinking. So for instance, instead of giving them the steps, then doing the base 10 blocks, we want to do the base 10 blocks first and then ask them what patterns they noticed. Then we can talk about the steps because those are very abstract. In a similar approach, if we wanted to use sociocultural theory, we could highlight the importance of learning through interaction and scaffolding from either a teacher or peer and guiding students to their zone of proximal development. This could include peer-to-peer work, group work, coming to the front of the class and doing an example problem, or any kind of variation that gets them socially interacting. Now let's talk about high-quality instructional materials. These types of materials should support learning theories in practice, and how we evaluate these materials for effectiveness requires reflecting on those learning theories. High-quality instructional materials are designed to provide opportunities for students to explore and construct their own understanding through really meaningful learning experiences. So as you're evaluating that curriculum, you want to look at it and you want to think back to, okay, what are the different theories that I know? In what ways did these materials facilitate the use of a theory to help students learn? When we're looking at these, we have several different key criteria that we need to consider. And the first is it needs to align with the learning goals. When I'm looking at the curriculum, those standards and learning goals should be very tightly matched to the instructional materials. This ensures the materials are directly supporting the key objectives of your lesson. For instance, if the goal is to build a deep understanding of place value, materials should provide activities that encourage students to explore the structure of numbers, like using base 10 blocks. So let's look at another example. If I'm evaluating some instructional activities for a place value lesson, I would want to check, do these activities allow students to manipulate something with their hands, like base 10 blocks? Are they doing an exploration in some way where they're creating or constructing a pattern of knowledge? Are they looking at how different digits in a number represent different quantities in the blocks? So are they connecting the actual number symbol to the quantity of the blocks? If the material only focuses on a drill, a worksheet, memorization, repetition with no meaning and no actual construction of knowledge, then this is not really going to be considered high quality. We want to make sure that there's some type of hands-on, there's some constructing, there's some social interaction, there's some peer-to-peer, there's some differentiated instruction, and all of those types of things. The next one is opportunities for exploration and conceptual understanding. High quality instructional materials should provide opportunities for students to engage with math concepts in a hands-on exploratory way. That's probably one of the biggest criteria that I could be able to give you, is that they really need to follow that process. And so suppose you're reviewing a lesson plan that uses a number line. A high quality material would encourage the students to use the number line not just for practice and looking at it, but to really visualize the relationship, to put their hands on it, to move the numbers in the right directions, and maybe even something like, can you predict the result of 36 plus 47 and where it would be on the number line? Because we want them to interact and be hands-on with the number line itself, so it fosters deeper understanding other than just calculating a basic answer. Then we have incorporation of multiple representations. Effective, high-quality instructional materials present concepts in different ways, so they shouldn't just teach it in one method or applying one component. It needs to be concrete instruction. Then maybe it's got pictures and images. Maybe it's got some different abstract representations, so that students can make connections across different methods. This aligns with Brunner's theory of representational learning. If you're not familiar with this theory, it stresses the importance of progressing from concrete knowledge and being things that you can touch, like a manipulative, to something that might be a picture, which is a diagram, and then to something that is an abstract representation. So to be a high quality instructional material, we need them to go from hands-on touching and doing to diagrams or picture representations. Then we can introduce number symbols and simply regrouping and using the addition without those different aids. So a set of materials that we're evaluating for high quality for subtraction might include using manipulatives similar to base 10 blocks and number aids like a number line. So they could include either one. It's something they can touch, it's something they can experience. Once they've completed that experience, then we can move them on to pictorial representations, like having clusters of apples or having clusters of these things, and we're seeing the subtraction happen. Then they can finally move on to the number symbols. And this should be scaffolded even as they get into higher grades. We want to make sure we're following this process. So when you're evaluating the materials, really look at if students are given the opportunity to move between these different types of representations, which will reinforce the understanding at the conceptual level. There also needs to be support for differentiation and scaffolding. Not every learner is the same, and we cannot expect a learner to be successful if we have not built the ladder for them to climb. High quality instructional materials should provide opportunities for differentiation, enabling a teacher to adapt the lesson for students to be at different levels of understanding, different modalities, whether it's auditory, visual, kinesthetic. and it really should provide a solid ladder for them to climb. Now, when we talk about scaffolding, this is very heavily related to Vygotsky's concept of scaffolding. And he says that scaffolding is materials should offer guidance for students to take them from point A to point B on that journey, again, from hands-on touching to to pictorial representations to symbols. So we need to go through that. So if we're going to scaffold on this, as we're looking at these high quality instructional materials, there should be guidance for teachers on how to do this. This is not something that if it is a high quality material, it's not something the teacher should have to come up with from scratch on their own. So if you're looking at evaluating a lesson plan on addition and subtraction, a high quality plan would include ways to modify this for students. Maybe it has a suggestion for a remediation activity using manipulatives with base 10 blocks. Maybe it even has a challenge for advanced students with some more complex problems. If the materials do not offer something for differentiation and scaffolding, we cannot call it high quality in that criteria. Last, a formative assessment integration. Good high-quality instructional materials include opportunities for formative assessment so teachers can gauge understanding in real time. These are the moments where we take a pulse check and we're asking a question and watching to see how students react. And then as we watch them react, we adjust our instruction. If they looked really confused and bewildered, I'm going to keep teaching. If they look bored and they're answering quickly, I'm going to move on. So we want to see moments and little quick checks of things that you can do as an instructor to kind of check the temperature in the room so that it supports and allows you to adjust your instruction. It also keeps the learning process kind of continuous, and it helps teachers from getting stuck on how to pivot and adjust. So you might look for something like a built-in checkpoint. A quick check is sometimes what it's called. A couple of reflective questions where you ask students to kind of reflect. Maybe even some basic activities that they're doing at their seats. And those, by watching how they react and interact with that, you're going to have a better idea of their process. So let's apply this by looking at some common tools used in numbers and operations in base 10. So if I'm talking about base 10, we typically use a lot of manipulatives, number lines, like visual models where I've got my apples minus this many apples that really support student understanding. So if I'm looking at base 10 blocks, let's think about a second grade lesson on subtraction. A high quality material would let students represent 63 using those blocks, and it would let them also represent with 6 tens and 3 ones. I'm sorry, I lost my track. And then if I want to take away and I want to subtract some numbers from there, I should represent the second number with the base 10 blocks, or I should simply take them away from the original grouping of blocks. Then you're going to have to do things like carrying over so that you don't wind up with negative numbers, and doing all of that with the blocks themselves. So they should be borrowing and moving just like they would in subtraction, but doing it all with their hands. Then there should be a different activity that supports it visually with some kind of pictogram, diagram, or something else. And then we should have some quick check questions that let us do it symbolically. Now, I won't say the absence of any one of those would knock it out of high quality, but ideally we'd like to see a checkpoint for each one of those levels. One for concrete, one for pictorial, and one for abstract. That would be like gold star perfect, but not every curriculum is going to be that strong. So if I'm also looking at using differentiation and scaffolding, there's kind of this intersection of a Venn diagram of these three things. And as I'm considering analyzing the work and the misconceptions that might happen, I need to consider each one of those. The scaffolding, I need to consider the differentiation strategies, and then where do they fit in that zone of proximal development. So if I'm looking at analyzing student work, It's really essential to look at that instructional material and see if there's any misconceptions, or even if the material points out you may have students that mistake borrowing for something else. That's going to be really helpful to be said in the instructional material itself. So looking for it to kind of give you some points that's guiding you as an instructor, that's going to be really positive. So let's say that a student adds 56 and 29, they get 515. And you're like, how did that happen? As a teacher, we would want to look at their work, and we would look back on their work to see what happened. And maybe they got their place values confused, or they regrouped differently. And so here it could be a simple misconception with their understanding of place value, which then you can address. So when we're looking at those high quality tools, we'd really like to see some examples of saying, hey, you might see that students might struggle with place value. We'd also like to see some diagnostic teaching. So this is where there's a break in the curriculum that maybe gives some example problems that students could try to solve, or some extra resource problems outside of the regular examples that people could utilize. And if you have those extra problems at your fingertips, then that makes those materials that much more powerful, because you're not trying to rack your brain to come up with something to be able to do with them. And when you're analyzing student work, you're not just thinking about those misconceptions, you're also trying to think about different insights, and you're also trying to do a lot of adaptation with strategies to address a misconception. So anytime those instructional materials can have things like, here are the common errors you might see, they're going to identify them in the materials. Here are the formative assessments, the extra questions that you can ask students to explain, and it kind of gives you a pulse check. Here are some adaptations you can make to how you're teaching to address misconceptions. So if place value is a common misconception in the materials and they're telling you that, ideally they would have an activity that says, if your students struggle with place value, here's what you do. So some key takeaways from this lesson is that learning theories like constructivism, sociocultural theory, and teaching practices intersect with evaluating high-quality instructional materials. We want to see conceptual understanding occurring with those hands-on touch moments. We want to see them moving from that conceptual understanding to that pictorial understanding, and then to that abstract thinking. We also want to see multiple representations of information so that it supports varied representations for students to make the connection and to deepen their learning. And we really also want to see that they are telling us what the possible misconceptions could be and how we could address them, because it's overwhelming as a K-6 teacher, especially if you're teaching multiple classes or multiple subjects, just depending on where you are, and those instructional materials are not carrying some of that burden for you, because you're going to have 100 other pivots to make in the classroom, because there's 100 other things that could occur while you're teaching that you're going to have to pivot to. So if your instructional materials can follow these quality guidelines, it will equip you as a teacher. And as you're considering curriculums and what gaps and your lesson planning, if your curriculum doesn't have these things, then you're going to want to reflect on them and then include them in the curriculum.